My name is John Daas. I have a company in Amsterdam doing penetration testing, security testing. As part of our work and our hobby, we do also all kinds of research. One of those research things is looking at SMS and web. Web is the W80 kind of web. So now I have to go to this whole ordeal. I did this talk a month ago, and I used a PowerPoint presentation. I was going to convert it to Unix because this is a hacker event, but I was too lazy and too slow, so I did it to VMware. Okay. Which kind of works? So, okay, we're there. Okay, so my talk is going to be about mobile security. I'm going to talk about issues that you run into with your phone, mainly. So it's not so much geared towards more advanced mobile or wireless technologies, but mostly what can happen with your phone. I also said a little bit of web. Didn't say so in the title of my presentation on the schedule. The reason is that at Black Hat a month ago I did a talk on both SMS and web. I had a little more time, so now I'm going to do a few demos, I hope, because there are some problems there too. And I'm going to concentrate first on the SMS part, and if there's some time left, maybe I'll go a bit into the web part too, but we'll see how it goes. So, what I want to talk about first is a little bit of the context of this talk, so that you don't have too high expectations, too low expectations. First of all, I'm not going to talk about the underlying technologies, not about GSM. This was also for the States, so you have CDMA and TDMA. I'm also not going to talk about it from an implementer point of view. I've never built a system with these tools. I've never set up a web gateway or an SMS sender for a telco provider or anything. I just looked at it from my perspective. Not about actual exploits. Well, that's not really true anymore for this talk because I do want to do a few demos. So as I said, it's a general perspective on what is it? What is SMS? So everyone knows that you can type some text in your phone and then send it to somewhere else, but what is happening technically in the phone and how does an SMS work? I've been a hacker and breaking systems for about 10 years, so I have a certain perspective on these things. I tend to look for things that would break something, and I want to show the issues that you can have with things like SMS, and maybe give a feel for the problems that we might encounter in the future. So why would you be interested in this talk? Some things I can think of is that you're interested in how it works, that you are asked to evaluate it, that you do want to do research yourself when I have some startup, you know what you're into. And for a lot of people that know a lot about internet security and computer security, but don't really know much about phone-related stuff. Okay, so first of all, there's a general statement about mobile security. What's the problem with mobile security? And when you look at a phone, typical phone screen size is, I don't know, 4 lines, 5 lines. There's hardly anything to see there, and it's all crammed in one little space. And because there's a little space, people leave out a lot of stuff, so it's really hard to judge what you're looking at, because they leave everything that's not really necessary out of there, and there's often no way to retrieve any information that tells you a little bit more about what you're seeing. So a good user interface is very important for security and for trusting. So if you look at all the problems we've seen with browsers and talking about locks, and you need to look at your lock, it's closed, and blah, 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 and look at the URL, that it's the right URL. So how are you going to do it on a user interface that's small? If you look at the standards that people are writing, standards are all geared towards that it should work, functional. It should do this. Standards don't go very far into precisely how it should be done to avoid making mistakes in the actual implementation, and also they tend not to go very far in all the stuff you shouldn't do in your implementation. And then the all-over risk, and maybe not yet so much with phones, but with the PDAs, it's another general-purpose platform with all the associated risks of mobile code, virus code, all kinds of code that you really can't trust and still run on your system. So that's some general stuff that you will see with mobile systems too. Okay, so what are these things? What are we talking about? Well, first of all, you have the cell phone technologies. That's the technology that the protocols that describe how the airwaves work, how the backend systems work for finding the phone that you want to talk to. These are called GSM and TDMA and CDMA. On top of that, or maybe a little bit inside of that, you have short message service, SMS, which is like paging style messages. And on top, and that's really on top of the GSM layer, you have WAP, the wireless application protocol, which is doing the mobile internet stuff. And for that, there's also a whole separate set of specifications. It's typically a whole redesign of what we have in the internet world, but then geared towards a small device with little memory, not so much CPU power. Okay, this whole field is governed by a whole bunch of standards. First, you have the GSM group that had standards, and they numbered them GSM and then number 03.40 or something. When that started to grow, then ETSI, I forgot what the thing is meant to be. Well, I'll get to it. They have a special mobile group, and they took over the guiding of those standards, and they started renumbering them. So you have the TS, and then mostly 3 numbers, space 3 numbers. That's a new standardization scheme. And now with the coming of UMTS, there's a whole new group called the 3GPP, which is more or less a worldwide combination. ETSI is part of 3GPP. And they again devised a new numbering scheme. So you have now lists matching all those numbering schemes, and you have typically of every standard about 10 versions. So it's pretty big. I think no, I don't have numbers, but I think here. This is about this is called paperwork. It's just SMS specs. So it's web is another thing. The web forum is doing the web-related specs, and they have a separate site, and that's again also quite a book standards. So standards are pretty important. Standards tell how it should be. If there's a mistake in the standards, then that's really bad, because then everyone is doing what the standard says and it's still broken. But what you often see is the standards is or too vague, or what I said earlier, and that people implementing the standards maybe comply with the standards, but are still security-wise or functionality-wise broken. So that's the whole intro. Now a little bit about SMS. First, I want to go over the SMS description. What is SMS? What does it do? Then more detailed into the format of SMS. So what are the fields? How does it work? How does it get sent from one place to another? And how is that sending dealt with in the format? Talk a bit about short message service centers, which are playing an important role in how the SMS message gets to the end user, and their associated protocols. and then go a bit into the new features that SMS is being used for, because everyone knows it as the thing to send a text message with. But if you have a Nokia phone or something in your phone, then you know that there are a whole bunch of other things that you can send also these days. First, the simple stuff. SMS is a store and forward messaging principle. You have in the point-to-point, BP, and the self-broadcast ways. The point-to-point is you have one destination, and self-broadcast is, okay, I as an operator, for instance, want to have this SMS go to this whole, like multicast, whole set of phone numbers. It's delivered through signaling in the phone system at several levels, and it's also in the it's called the radio interface. It's also sent separately to the voice channel, so that even if you're speaking on the phone, you can receive an SMS on your phone at the same time. The SMS itself has a payload of 140 bytes, which is 8-bit, but there's a scheme which encodes the normal ASCII of 7-bit into the 8-bit, so you get 167-bit characters, which is the normal limit to here. And where can you send it from? Well, normally from your mobile phone. That's the typical thing. And in your mobile phone, you have a phone number which is called the number of the sender, and your mobile phone contacts the sender and delivers the SMS for processing there. But there are a whole lot of other ways. These days we know about email gateways, about web interfaces where you can send SMS from. This all works because all the SMCs have interface protocols that are meant for interfacing. So you can do it from DSM modem, from a PC dial-in, X25, TCP/IP, whatever the operator decides that he or she wants to have as an interface, then you can more or less send it with it. And again, that works with spaces. So, picture a little bit how it looks all the way to website. The end users, they contact the SMSC, the short message service center, which contacts the mobile center, which is the actual operator that can look up your mobile in the home location register or the visiting location register. Where is your mobile phone? So where can we deliver it to? And if it's in the air, it gets delivered. If it's not, it gets stored until you get back into the system and it gets delivered at a later time. So that's pretty much the picture. In fact, really simple. Okay, so now we go a bit deeper into the bits and the bytes. I hope it's not too technical, or maybe people find it not too technical yet. So both parties get their share. Basically, there is a message format, and it begins with type. So the types that we have is to deliver. These are the basic types. There are a few more, but the delivery port. If you know your phone, you can set it. Most phones you can turn it on, and you get reports if it's pending or being delivered to the end user. That's a delivery port. For submit, there's the same thing. Submit is what the phone does to this SMC, and deliver is what the SMC does to the mobile station, MS. Then there are special commands that you can run on SMS messages that are already in the system and that you maybe want to delete or query. Those are not so good. So basically what you do is pack it in a big field of data. I'll go over every entry here. First of all, the message type indicator is simple. That's what I just showed. That's okay. Is this a met or a redirect? Then we have the reject duplicates. What you can have is that in the SMC you can have an SMS waiting for delivery, but then the data gets old and there's a new SMS which overrides the data in the previous one. And then duplicates can be rejected, so the old one will be deleted and the new one will be the valid one. Then you have the validity period format. Further on there's a validity period that says how long is this SMS valid. There's you can have like a timeout. After so many hours or so many days, this is no longer worthwhile, so then you can delete it. The format can be absolute or relative. The next field is the reply path. What it does is this gets copied in the deliver message that goes to the other mobile phone. And it signals the mobile phone that there's a desire from the sender to use the same SMSC as the message was sent with for the reply. So normally you have in your mobile phone your preferred central number, and your phone will use that number for any SMS that you send. If this flag is on, it will ignore that number, or it may ignore that number, and use the number from your message for the reply. But we'll see that in the next slide. Then we have the user data header indicator, which says, okay, this message contains the user data header. I'll get back to that later. You can have a status report because you can have the message reference number so that you can refer to it when it's in the SMSC. You can request updates on its progress. The destination address, of course, a protocol identifier, and this tells a little bit about how the mobile station should interpret this message. There's a whole range. If it's like, should it be like a fax or should it be like a normal message? There's one interesting protocol ID that says that this can be a SIM data download, which means that there are certain types of SMS that get downloaded by the mobile phone to the SIM card, the smart card that's in your phone. There's a special protocol going about how that should work, and the protocol identifier plays a role in that process. The data coding scheme tells you what format is this message. Is it a 7-bit ASCII? Is it 8-bit? Is it another special format? Or is this maybe an indication? There are a whole set of indications. There might be a voicemail message waiting for you. There might be a fax message waiting for you. That's also set through the data coding scheme. Validity period is clear. User data length and the data itself. Okay, delivers pretty much the same thing all over. What you see here is the originating address, of course. It's in there. What I'm looking for, but what I'm not completely sure about now is the SMSC address that's used for delivering this message, which is also known by the phone. Because the reply path is set, the phone, and I tested with my Nokia, the phone will use the SMSC phone number that was in the SMS that you received. So in theory, you can have a situation where there's an SMSC that is not to be trusted, and SMS messages sent through that SMSC can have the reply path set, where your phone will send a reply to that SMS, again to that rogue SMSC. And you will never know that you've not been talking to the person that you thought you were talking to. And your answer also went back to the person that initially was not to be trusted. So there's a problem there. And in fact, what should happen, of course, is that there either the default should be not to use it and ask the user if you want to do it or not. But what I saw in my phone is that it just starts using that SMSC address. Okay, so these are the normal submit messages. As I said, there was a flag called the user data header indicator. What this does is you can send more stuff than only text messages. You can send ringtones, you can send logos, you can send kind of key cards, business cards from your phone. And the way this works on not all, but some of the mobile phone manufacturers is by use of the user data header. User data header is like a special header that gives you more information, and it's like what you see here is a flexible way to add that information to the message about what this kind of message might be. What you see here is simple. The scheme is you have a length the whole field. There's a user data length, and then you have the user data header length. And then you get the IEI fields, that's the information elements. They have a type, a length, and optional data. So if the length is 0, there's no data associated with it. If it's port numbers or something, then there go the port numbers. And then at the end is normal data that your payload is that you want to send. So this type is used with the information element identifiers. And they have these meanings. First of all, you can send concatenated messages. So this is the fragmentation in IP. You can send, or should I say, easier. You can send more messages, also in IP, of course. You can send more messages that get reassembled in the mobile station at the end. So simple test shows that if I send a concatenated message and I send only the first one, I get no response from my phone, but the SMS is received in my phone, and I won't know anything until I receive the last SMS, which gives you an idea of, well, how does it work with starvation, or what kind of resource allocation will be going on if someone receives 54 messages and then maximum size and then not the last one. And what happens with those messages? Well, they're all waiting for the last one. Is there a timeout or anything? There's no specification on what should happen. So that's an example. Then the 8-bit port and the 16-bit port are comparable to UDP. There's a big analogy between UDP packets and SMS messages. That also goes into the web part. So in web, SMS can also be used as kind of a UDP packet. The ports are used for that, but they are also used for the linked ringtones and logos. So in your phone, there's surface listening on a certain port, and that's the ringtone port. And if an SMS message gets sent to the port, it will be interpreted as a potential ringtone. So it also goes with the logos, etc., etc. But it's also the port number that the web protocol works on. Okay, then there are some SMSC control parameters that talk about how long to store, etc., etc. What's interesting, the WCMP is also web-related, which is also a bit weird because it's one of the few things that you find in the DSM specs that's related to the web protocol. But it's like with the port allocation in IP space, you can ask for a number and then it will be assigned to you. The SIM toolkit is a way that I was describing earlier, where you can send SMS messages that will be handled by your phone to talk to the SIM card inside your phone. And there's a whole protocol going on about that. I'll talk about it a little bit later. But you see that that's also where the user data header gets in use. Okay. So, and then from the simple SMS messages, we went to the smart SMS, as Nokia and Ericsson named it, and that allows sending of all these new features. As with all things, you can expect when features get added, problems occur. As soon as we start doing implementation, things break. So that's the big risk of all these things. A special case of it is OTA, it's over-the-air, sorry, yeah, that's also another, that's open telephony application or something. But over-the-air means I can configure your phone over the air. And that's handy because if you know your web configuration in your phone is complicated, you can press 1,000 buttons and no one is going to explain that to an ordinary user. So what they do is they give the opportunity to the operator to send an SMS to the client phone. Okay, this is my, we have TCP or something, and this is our web gateway configuration. And you say accept, and it gets configured for you. nice trick, of course, is to send an update, maybe with a spoofed SMS, and have a new OTA setup that uses your phone number or a high charge number, or uses your web gateway so you can be man in the middle or whatever. So more options, more possibilities, more danger. Okay, as I said, a big interface to the SMS world is not only your phone, but also the interfaces that the SMSCs offer through their specific protocols. And what happened in the SMSC world is that a few big vendors wrote whole software systems to handle the SMSC, CMG, Nokia, Logica, SEMA, or also a few others. And what happened is everyone decided to code their own interface specification. So if you have a telco operator buy stuff from this one, then everyone has to interface using that protocol. So in Holland, we have KPN using CMG. So the protocol is called EMI or UCP to talk to it. Libertel is using SEMA. So there are a few others. These protocols allow you to specify all the bits and fields that I showed earlier. Some allow you to specify a bit more than others. Some also allow you to specify extra additional stuff for such a message that's not directly related to the content of the message. The SIM toolkit is, like I said, it's the SIM card, it's the smart card that's in your phone. It's a subscriber identity module. It takes care of the crypto. It can store some telephone numbers for you. It keeps your identity. What they did is they extended the API to that card, which is so far it was quite a traditional interface with traditional smart card comments. They extended that comment set to do much more interesting stuff. For instance, the SIM card can tell the phone to display a menu for the SIM card. So now you have the phone, and without the SIM card, the menu is not there. If you put in a SIM card, there's a new menu. And if I put the SIM card in another phone that's supported with the SIM toolkit, the menu is now in that phone. So the menu goes with the SIM kit. So it's like the phone pulls the card, and the card tells the phone what it wants him to do for it. Part of that API is also to do communication with an external party over SMS. So if you set the protocol fields right and the data coding scheme right, you can talk to that card. The specification goes quite deep into the protection, of course, because SMS is plain text, it goes over the air like that, everyone can snip it or intercept it. So they use the crypto keys in the smart card, if you can't get it, to crypt the communication. In Holland there's now a phone from the Postbank, which is a bank, and they have a mobile banking application. And part of that application is also based on this technology. And if it's done properly, it's pretty safe. It does has the provisions to do proper crypto. The scary part, of course, is that someone does make a mistake, and then it starts to become a remote problem. Because let's say that it checks if the crypto is there, but if there's an option not to use crypto, or if there's an option that's not used and the card accepted as not used crypto, you could send comments to the card to, for instance, query personal information or something like that. So there are risks associated with it, and you can wonder how well stuff like that is tested. And while all this is going on, you don't see anything on your phone. So, or at least it can be made very hard. So, to round up a bit about SMS threats. First of all, we have simple spam. Like with email, there are a lot of similarities between SMS and email. The telco providers have a lot of problems with the spam. Contracts they make with their clients and immediately they start spamming high charge numbers, call me please, and stuff like this, and they work. I mean, it happened here, I think, on New Year's Day or New Year's Eve in Holland, that people got SMS, please call me, or Happy New Year, call me back, with this kind of information. So, and if you do that a few thousand times, then you know that your percentage will be pretty interesting. Also, the public gateways and public websites to send messages are fixed to it. There's now on Lycos, I saw recently, they use a graphic image with a number that you have to retype. So to script that, because what everyone's doing, scripting, the sending, you need to do some OCR and script it. It's a problem, but it's an annoyance for the end user. Again, there's no way to filter it for the end user also on the phone. But it's not really a security problem in itself. Another thing with SMS is that there's no trust in the source of an SMS message. The way it's constructed, it's so open. You want to be roaming with your telephone, so you want to be able to go everywhere. You want to be able to use any SMSC that's out there. The whole network is interconnected, and there's no way to say this is a border, except maybe for one telco in itself. One telco can say, I can check if something is coming outside of its own network or if it's really from its own mobile phone. But other than that, messages go like crisscross all over the place, just like ID, but it's even harder to do ingress or egress filtering because you can have roaming users. So spoofing is a problem, and it works. If you have the SNCs that I showed with the protocols that interface, and these are open often or semi-open, you can use those with a simple software to fabricate a message, and you can specify any source that you want. There's the more difficult case that I explained, where you can have the reply path indicator, but that requires that you are an SNC, and I'm not sure how easy it is to completely take over such a role, but the world is big, so I wouldn't be surprised if there are places where it's easy. So now I have prepared a little demo. Maybe there's a volunteer. I haven't set up my thing again because whoop. I have to set up. I had it all nicely prepared until the reboot. Oh, right. Yeah, I also had it prepared because it was a bit more visible. Right. Okay, now everyone can read it, I guess. Right. First of all, if you start just a terminal emulator, and you couple your phone and the modern phone all have AT common interface to your ESM modem. So it's just an AT modem. I can just, and it works. So that's a protocol that can be used to dial out, but it can also be used to send SMS messages. And there's a tool out there called DSM-Lib, which uses this interface to actually send SMS messages. Only these are only to submit PDUs that are, the full PDU that I showed you earlier, the whole field bits. Those get sent through this interface. What I'm now showing is just using the mobile phone to dial out, like a normal modem. I'm not using the PDU interface. And now it's a big test because I talked to a journalist yesterday about this, so he was really interested and started calling KPN and I don't know what to verify this. So I'm not really sure if this ruined my demo now. I've tried it before and I have weird results, so I'm not completely convinced anymore that it worked. Anyone has a mobile phone? I was asked to ask if everyone would turn it off, so I didn't do it, so I'm now hoping that people will forgot and have them still on, and I can try and send an SMS. So, give it to me. Is it Dutch somewhere, or? Yeah. Okay. Yeah.
Yes.
Okay. That could be. This is going to take a while because it's. I haven't counted on this audio demo. This is what GSM sounds like, so you can see it's all encrypted over here. That's pretty annoying. Okay, so, and here we see a message, which is the format that's used by UCP or EMI, which you see as all the slashes. There is your SMS. The only thing that you will see is that your own numbers and stuff. So, what now you see your own number probably, or did you see your name, or? No. Okay. Most of the time you don't have your own number in your telephone book, but for instance, Nokia phones, you get the name of the person that it's spoofed at. For simplicity, I just make it the destination same as source, but you can have any source and any destination. Also cross telco. I mean, it doesn't matter that you're sending to one telco and source is from another. No, because this is maybe caller ID. If they check caller ID online, but I can turn caller ID off if I want. So, and I can use it. So this is not tied to my mobile phone. In this example, it's just a modem. So if I have any other modem to work, sure.
If I'm correct, you can always know your caller ID. Even if you turn it off, there's still no. It's just.
Sure. But let's say I'm not even sure if that's true for cross telco.
Yeah. Yes, it is.
So because I have a Libertel thing, and I'm dialing into a KPN dialing, it's a public dialing. So. But then they have some internal numbering scheme. But the way the SMS is processed here is completely unrelated to the dial-up now. Because it's a normal modem dial-up, and the dial-in that I'm using is the same one that they use for their normal PC to SMS software. So it's a normal interface, and the PC software doesn't fill in that field, and you get like a random number or a sequence number. But the protocol allows you to set certain fields. Not all the fields are allowed to be set. They have certain fields. For instance, you can, with a PC, check this message, and then you can see it's not from a real mobile phone. Because the protocol ID can be used to identify the type of originator. And the originator field I'm not allowed to set. I have to have a contract with KPN to be able to do that. Yeah, this is
What's the maximum length you can deliver?
yeah, often alphanumeric.
Doesn't allow you to use space.
No, and I'm not even sure if you can use this without a proper. So the question is, well, I'm not even sure what the question precisely was, but anyway, what would happen if you left something out, or what's also possible to send SMS with alphanumeric text. So you can just hard code the name in there, and there's no way to check what phone number it was. Also, the Lycos site is also allowing you to specify any number, only they put in adverts in the SMS message so you can see it. So in general, this is not a strange thing. It's just the way SMS is supposed to work, and it can't really be used to trust upon. So, okay, this was the first simple demo.
To summarize here, you've made yourself an SMS submit. Why you?
Whoops. Oh, sorry. I made. Oh, I want to go back to the screen. Oh. You were asking.
You make yourself a script, SMS by itself, which made an SMS submit, which looked like what you highlighted now.
Yeah. What I've highlighted now is the message in the UCP protocol to the SNSC to build an SMS from this information, and every slash is a field. Some fields are blank, there are defaults, some fields are filled in. I'm using OT51, that's 51. This is the destination number, and this is the originator number. And I can fill in any number that you want. You can also use international numbers, so you can do 0031 and then it will also go. So I can also dial to D2 in Germany, which is also a CMD SMC, it works the same way. And if I remember correctly, Belgium is Proximus, which also does this. So the body text is shifted off the screen, sorry. There, it's 3 bytes. Yeah, so it's type 3. Sorry, type 3 is normal ASCII message, and then it's not really that significant. It's only to show that the source of SMS is not to be trusted, and the system is meant to be that way. Now I completely killed my presentation, so go back there. Go like straight to where I was. Okay, so that was spoofing. What's even scarier is, of course,